I'm surprised if you're back. I thought I was gonna scare you away with that first part after all those 10s to do this and 10s to do that. Hey, but if you're back with me, that's awesome. So we're gonna do our best to show you a little bit more analytically what a limit is, right? So without further ado, let's go ahead and start the second part of limits. Here's our graph. Mainly because I just love writing on this tablet. And we're going to draw a little function. But don't get too freaked out by the function. Don't be like, oh my god, why is he writing that function? It's just an arbitrary function. Right? It's just really a line that I felt like drawing. And we're going to label it f of x. Right? We're going to label our axes x and y. And we're going to make some points here. We're going to just make a couple points. We're going to look at this point right here. Right? And we are going to say that is an arbitrary x of c. And its corresponding y value is just f of c. So that shouldn't be too confusing. But if it is confusing, maybe I'll make a video on, on these graphs, or you should probably go back and read your textbook a little bit to understand what these notations mean, c and f of c, right? All this is, c is just it's an arbitrary number. We are calling it c because we don't want to say 10, 20, 30, 40, 50, 60. And we are calling this f of c because it is the y value, so f of c, the function of point x equals c, where the y value is f of c. Alright, and very good. And we're going to see what happens if we go to a limit. So, the limit, and you remember from my last video, how we define limits, how we write limits. It's hard to forget anything I said in the last video, right? X approaches c of f of x, and we say that is equal to, take a guess, I'll give you a drum roll. My awesome drumming skills. That is going to be equal to, that's right, it's getting closer to f of c. I said that's right, because I assumed everyone got it right. But if you didn't, let me go over why it's f of c. So, as x is approaching c, right? Let's do this in red. That means that, watch our line here, it's getting closer to c, so it's following this, da-da-da, na-na-na-na, boom! It's getting closer and closer to that number right there. What's that number? I'm pointing to it on the screen, like you can see me. What's this number right here? What is this? What's the y value? What's the y value? That's f of c, guys. That's f of c. So, as we are getting closer to c in the axis, we're getting closer and closer to f of c on the y-axis. And then we could do that from the other way. Whatever this is out here comes, and then it gets closer to f of c here. So that is why it's getting closer to f of c. So we can take this theory now, and we can use it to a whole bunch of problems. So let's try problem here. Let's try problem 1. Let's see what happens if we try to take the limit as x approaches 0 of, let's try x squared plus 4x over x. Let's try that. Pause it and try to do it on your own first. If you are totally lost when you see this, try to look at my first video, or try to go ahead and watch my first video a bit to understand what a limit is. A limit is what a function is tending to, what value a function is tending to as x approaches this number. So we're looking for what this function is tending to. What is the y value of what this function is tending to as x is approaching 0? Okay, so here we go. Let's go ahead and take this away. If you got it, congratulations. If not, let's do it step by step. So what happens as we approach 0? What's happening at 0? Let's evaluate this function at 0 first to see what's happening. So f is 0. That means we put 0 in for x. We get 0 squared plus 4 times 0 over 0. That means we get 0 plus 0 over 0, which is equal to 0 over 0. And oh my god, we know that we cannot have that, because 0 over 0 is probably one of the worst things that can happen in math, because I don't know what, and I don't think anybody knows what 0 over 0 really is. It's the epitome of everything evil in this world today, 0 over 0. So that is just not happening, right? That's not happening. But what's really weird is that we can still take a limit to this function, even though the root of all evil occurs at f equals 0. How can we do that? That's a good question. Let's try factoring, shall we? Because back in high school, teachers kind of taught you that factoring can solve any problem that you ever encounter. It could solve world hunger and create world peace. And let's factor this out and see if those guys are right. We're going to pull out an x. And if you don't remember how to factor, there's a lot of awesome algebra videos out there. I'm going to make some of my own algebra videos when I have some free time. So don't fret. But you probably should review it if you're in a class. Okay, so that's factored. And guess what now? Let's change this to red so we could do it. But booyakasha, booyakasha. X's cancel out. And we are left with just x plus 4. Well, guys, now it's a totally different ballgame, isn't it? Because look at this. It turns out that the limit as x approaches 0 of x squared plus 4x over x, that's the same thing as saying the limit as x approaches 0 of x plus 4. So you know what this is like? This is like a small little dog that has like this loud ass bark, right? But when you take off all of its fur and stuff like that, it's really, when you take out its bark, it's really just a small little dog, right? It's just x plus 4. So what's happening as x approaches 0 of x plus 4? Well, it's getting closer and closer and closer to, take a guess, drum roll, 4, bam. So it turns out that this huge, complicated thing of x approaches 0, of x squared plus 4x over x, blah, 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 is just the same thing as saying limit as x approaches 0 of x plus 4, and that's equal to 4. So that's awesome. If you don't believe me, let me bring you to a little graph. How about that? And we could show you mathematically, we could show you graphically why this limit is 4. Let me go over here. Boom. You see how I already have the graph calculator up? Because I kind of knew I was going to graph something. I just didn't know what I was going to graph. So what was that? What was that function? X squared plus 4x. So you have to put it in parentheses. We're going to do x. No. Why are you going out there for? We're going to do x squared plus 4x. And that was all over x. So what should we get here? We should get a straight line, right? Because we're saying that this is the same thing as x plus 4. So we should just get the graph of x plus 4. X plus 4 is just a straight line with the y-intercept of 4. Right? A straight line with a slope of 1 over 1 with a y-intercept of 4. So let's go ahead and press graph and see if we get that. Oh, that is, oh my god. I was actually a little scared. I was like, oh my god, imagine I'm talking all confidently and then that doesn't come up. But there you go. So yes, this makes sense now. Because y-intercept of 4, slope, and as x is approaching 0, right? As we are approaching 0 here, y is approaching 4. That is awesome. So I hope that illustrated a little bit for you guys. I hope it did. But let's continue on. Let's try to do one more problem. How about that? I don't even know what YouTube does. Do they cut me off after a certain time? Like, do they just get tired of hearing me? I don't know. So if they cut me off while we're on the second problem, then we'll continue it in the next video I do. But here's problem number 2. Because we're on a roll now. We're on a roll. So we might as well continue with this roll. Let's try this. Let's try what happens as the limit, as x is approaching 6 of, what do we want to do? I don't know. Let's try, x squared, plus 3x minus 18 over do we want that? Why don't we make this minus? What the hell happened? Why did the whole thing get erased? X squared minus 3x, and we're going to say over x minus 6. That should work out. That should work out. So let's see. We're going to put 6 in, right? Because we want to see what happens as this function is approaching 6. I'm sorry, guys. Take your time, work it out, pause the video, see if you can do it. Come back, and then work it out together with me. So, here we go. Plug in 6. 6 squared minus 3 times 6 minus 18 all over 6 minus 6. Alright, so the top, we're getting some number, right? We're getting this, I don't know, call it C. We're getting some number. But the bottom is 0. Man, that's a problem. Because we know we can't have 0 in the bottom. So why do they keep doing this? Man, why you keep giving a 0 in the denominator, man? Why you keep doing that? No, but, sorry. I want to make you practice. I want to make you see this. So what can we do? What did we do last time? We tried to factor. Because factoring usually is, believe it or not, it usually is the answer to our little problems right here. So let's factor that top. We're gonna double bubble it. That's what they call it these days. They call it the double bubble technique. And we know that it's a polynomial on top. And there's going to have 2 factors that are multiplying to negative 18 and adding to minus 3. So automatically, if we know we're going to multiply to minus 18, we know we need a plus and a minus. And if it's going to multiply, you know it's got to be 6 and 3. So now all that matters. Or, I mean, there's a lot of things. 18, 1, 6 and 3. I mean, 9 and 2. But we know they have to add up to 3. Or they have to subtract to 3 in this case, right? But subtraction is nothing more than just adding different signs. So, if they have to add to minus 3, it means that we have to put the bigger of the 2 numbers, 6 and 3, all over x minus 6. I don't really go into huge detail how to factor there, because I kind of think you understand that already. But again, if you don't, I'll put up some algebra videos in the future, where you can review your algebra on factoring. Right? But here you go. Here's your new function. So this function is the same thing as this function. So let me write that for you so you know that. They are the exact same thing. Okay? And now, check this out. Check this out. Booyakasha. Booyakasha. X minus 6's cancel out. And we are left with nothing more than just, go back to yellow, x plus 3. So this big funky thing, the limit as x approaches 6 of x squared minus 3x minus 18 all over x minus 6. It's the same thing as saying the limit as x approaches 6 of x plus 3. There's no difference. So, don't get scared now. And certainly, if you're taking a test on this, if you're doing this for your own benefit, whatever you're doing it for, please don't go out and say, oh, here's the limit. I'll give you an exact answer. This is 36 minus 6, 12, 18, minus 18, 36, that's 18. Oh, wow, so that turns out to be 0 of 0, right? If I did everything right. So, that's it. Don't come back. If you get this problem in real life, if you're designing the next spaceship in the future, and this is a math problem that you have to end up solving to design the spaceship, don't be like, oh yeah, limit of x approaches 6, 0 of 0. No, please don't, because then the spaceship is going to come crashing down onto Earth. For some reason, it'll probably end up in my house, and it'll all be because you said the limit of this is 0 over 0. It's not. It's not. So please don't write that, because it's not. Voice is cracking again. My God. It's like trying to be embarrassed. So, x approaches 6 of x plus 3. That's equal to, that's not too bad, because this function is just getting closer and closer and closer to, try guys, 9. So don't say the limit of this function is 0 over 0, because it is not. Okay? It is not. With simple algebraic manipulation, you like the sound of that? With simple algebraic manipulation, we can get this undefined point to 9. Alright, guys? So, we're going to stop here, and we're going to pick up next time on some even more complicated functions, and we're going to see how that happens. Alright, thank you for watching, and if I haven't scared you away in these first 2 videos, then come see me on my 3rd video.